Good afternoon, everyone. I'm Anand Bora, Customer Success Manager at Moldex 3D North America, and I'll be presenting the webinar today on the topic Comparing Simulation to Reality using Mold Compensation in Moldex 3D. This is an interesting and very exciting topic, and I hope you will enjoy the presentation today. Today's outline will have some introduction and some basic understanding to make sure that we are all on the same page about what is warpage and shrinkage, and then how shrinkage compensation methods are studied in the industry, how compensation workflow works or is applied in Moldex 3D simulation world. We'll have a couple of options or a couple of models, gear model and a plate model to look at. And then we'll have a case study, and finally we'll review the conclusion. So, basic understanding, what is warpage? As we all know, differential distortion caused by uneven shrinkage or differential shrinkage can be termed as warpage, and it has various factors that can come into play in terms of causing warpage in a given part. Fiber orientation effect, temperature effect, or uneven packing effect are probably three that will be the most significant ones. But then also part design, mold design, process conditions, polymer PVT, fiber orientation, and residual stresses are critical factors that play an important role in the overall warpage caused in a part. Now, part design, when we look at part design, there's like different differences in the thickness or the wall angles, and those kind of part design issues can give rise to warpage. Also, mold design issues like feeding system or different cooling channel layouts, proximity of the cooling channels relative to the part on the core side or the cavity side, or imbalance in the cooling overall, inserts, pin sliders, actions, all of that will play a significant role in warpage. Similarly, process conditions, overall cycle time and speed and packing pressures will play the role. And then PVT material, and of course fiber, length of fibers, type of fibers will cause warpage differences in fiber orientation. Of course, the stresses that will stay in the part, be it thermally induced or flow-induced residual stresses, cause significant impact on the overall warpage